Okay, so in this question, Sean recorded to the nearest minute the length of time t it took him to complete his homework during the month of March. The table below summarises this information. Time t minutes, number of days. Draw a histogram to represent this information. Now before I would start to draw a histogram, I would make myself out a table using the data, and what I would put in my table are the boundaries of each class, which will tell me how to divide up each bar along a horizontal axis, and I'd work out the frequency density, which will tell me how high on the vertical axis to meet each bar. Okay, so if we have a look at the second, we can see the limits are 15 to 30, so the boundaries will be halfway between 14 and 15, 14.5, halfway between 30 and 31, 30.5. And I'm going to work my way through the table doing the boundaries. Now you'll notice I didn't start with the first class, and the reason being we don't know what was the number before the 5, and the normal practice is to use the same spacing or boundary as you have used in the other classes. Same with the upper class, we don't know what's above 90, but since we've been doing 0.5 above in all the rest of the bars, we'll do exactly the same in the first and the last bar. So this is going to go down to 4.5 and up to 14.5. The other thing to notice about your boundaries is the upper boundary of the first class is the lower boundary of the second class. The upper boundary of the second class is the lower boundary, etc. Okay, we're now going to work out the frequency density, and the formula for frequency density is frequency divided by class width, which of course is how far it is between the boundaries. Okay, this is another reason I like to make out this table. So this first case is going to be 2 divided by 10, 0.2, 8 divided by 16, which is a half, 0.5, 18 divided by 30, which works out to be 0.6, 20, 2 divided by 20, 0.1, and last but not least, 1 divided by 10, 0.1. So I'm going to need a horizontal scale that can go from 4.5 up to 90.5 easily, and I'm going to need a scale on the vertical axis that goes from 0.6 down to 0.1. So the vertical scale is going to be quite easy. I could just take one small square to be 0.1, or even two small squares to be 0.1. Now on the horizontal axis, trying to fit in 90. Let's have a look. How much graph paper do I have? 15. So I could 10, 20, 30, 40, 50, 60, 70. That's going to leave me a bit short. So it's only going to be 1 centimetre is 10. Now, to help me here, I'm going to put a break in the scale. And what I'm going to do, to make it easier to mark out, if you have a notice, these are all 4.5s or 10.5s, etc. So what I'm going to do is I'm going to make my scale go starting at 4. Okay, so that's, so when we start, that's 5, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. Now, So 1 millimetre here represents 1. Yep, so a half is going to be half a millimetre. So we're just going to start slightly to the left of the boundaries. Okay, so we'll start off with the first one, 4.5 up to 14.5. So 4.5 is just going to be here, and 15, there's 20, so there's 15, so 14.5 is just going to be the other side of 15. Now we need to go up to 0.2, so there's 0.1, 0.2, so we need to go up that far. Okay, of course we're going to have to label our axes, so this bottom axis is going to be number of days. Okay, and this axis is going to be frequency density. Okay, so this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and this is starting at 4.5 and going up to 14.5. Right, the next one goes up to 30.5, so there's 20, 30, so 30.5 is just going to be on the other side of that, and it needs to go up to 0.5, so there's 0.2, 0.3, 0.4, 0.5. So we continue that line up, 0.5, and we need to go across to 30.5, so just the other side of that line. And again, doesn't do any harm to put in the bar widths. And we'll continue this way till we get the rest of the graph drawn. So the next one, 30.5 up to 60. So there's 30, 40, 50, 60. So we're just going to go on that side of that. And we go up to 0.6. Okay, so we're just going to continue this line up to 0.6. This line here. Just up to 0.6, join this across. Now this one's 60 up to 80, so there's just the other side of 80 there, and it goes up to 0.1. So, and this last one also goes up to 0.1, so it's just the other side of 90. And we've labelled the axes, and we've got our scales in. Now just to double check, I'm going to put 30.5, 60.5, 80.5 and 90.5 in the axis, just to re-emphasise that I haven't put it at the actual point.